scientists, where we are going to be dealing with the descriptive analysis. And after we load the data set in our Jupyter notebook, we are going to perform data cleaning. So, and data cleaning can be explained like the before any analysis. It's essential to clean the data. In this step, we will check we will check for the missing value and handle them. For example, by filling them with the column means to ensure accurate analysis. That's just a little things I can say about the data clean. We are going to do that too in with that data set that we have. So, and also we are going to perform descriptive statistics. So under the descriptive statistics, we are going to provide a summary of the data, main features. We will calculate the key metrics such as means, median, mode, and standard deviation to gain overview of the data set. And also, we are going to do data visualization too. So under data visualization, that one will help us to reveal the pattern distribution in the data. So in this section, we plot histogram of total sales to observe its distribution. So and inside the code block to we will create a histogram. Then under the histogram, we use the total column sales to perform that. So we also have the correlation too. We do correlation. And the correlation analysis shows the strength of relationship between numerical variables. We will generate a correlation matrix. So, and the correlation matrix is called heap map. Heap map. So I don't know, maybe you have come across something like that before. Heap map chart. So it's a correlation matrix. So that we use in Jupyter Notebook and also in the Python. So also we have a simple linear regression to do too as well. So under this, we will perform simple linear regression to model the relationship between a single predictor. So and also under it, we will find the quantity sold and target variable, which is total sales. So and also we look at the data analysis help us to, and what data analysis help us to do in that the shape, what do we call it? The name of this simple linear regression. We want to look at the analysis, what it help us to understand. One variable influence to another, maybe they have the influence in another, maybe without quantity showed, total sales can never be made, or without the quantity and total sales, quantity sold can never be able to stand on their own. So we want to find the relationship between the two quantity and quantity sold and total sales. So we want to find their relationship. So and also we are going to look at the multiple linear regression too as well. Under the multiple linear regressions, so we use more than one predictor variable to model the target. In these steps, we will explore how quantity sold and discount applied together affect total sales. So and we are going to perform ANOVA analysis, which is an analysis of variance. So ANOVA is used to test for significant difference between group means. We apply this method to determine if sales vary significant across different regions. So and also we are going to look at I think my this thing is loading here. Okay, my Jupyter notebook is open. So we're also going to look at coming. Okay. Time series analysis. Under the time series analysis tool, that one help us to uncover the trends over time. So we example the data to monthly frequency and analyze the trends of the total sales over time. So and also we are going to answer some questions, some certain questions under each of them. So what are the average data sets per this thing? What are the relationship? If you are able to cover all this that you are going to do now, so we are going to answer those questions too as well. So now these are the outline of what you are going to use that data that I sent to you for. So now, have you opened your Jupyter notebook? Okay, okay. Now, we want to go step by step on how to do all this on Jupyter notebook. So, and I will be happy if you can just follow it as I'm doing it here too as well. So, we'll be doing it one after the other. Then, if you have any question relating to any of it, so just let me know so that we're able to go back to that. So as time permit us. So now I want to open new notebook. So under this, it's coming up, coming. Okay, yeah, it has load finish now. So under this now, according to our data that we have here on what do you call it, on our folder, do you download it? Do you put it on the download folder or you place it on the normal document? Hello, it's downloaded. I mean, you download it from WhatsApp, right? So you have to be careful with the parts. So now for this one now, my own tool is under the download. But before we proceed, we are going to load some libraries. I'm coming. Let's go back to our code here. So here we are going to load some important library before you start any analysis. So and here, let me just write it step by step so that you're able to understand what I'm doing. So now, step one, load the data set. So and then under the loading of the data set will come the explanation. Let me write explanation that you're able to understand what I mean. So in this step, so what I'm going to do is that you will be able to we will import our normal data set from anywhere you put it. Before you go, you import the necessary libraries before. Okay. Before we do any analysis, before you maybe load your data, you import the necessary libraries. And I've taught you how to do that. Yes or no? So you import the pandas, you import the Seaborn. So if you want to import the Seaborn, how can you import that? You know that you want to import pandas now, you import panda as what? PD. You want to import numpy, you import numpy as what? Are you there? We then display. So you want to import the Seaborn. What are you going to import it as? So this will then display the first few row. So those are the steps that we are going to follow. I'm just writing those instructions so that you're able to understand. So display the first rows of the data set to understand its structure. Now, now let's proceed. So these are the instructions we are going to follow. So we are going to import some important library for the analysis. And the first library we are going to import is we are going to import pandas. And what is the function of pandas? For data frame, right? Yeah. So and also we import Seaborn too. Import Seaborn. Okay. Seaborn as SNS. So and also we import Matplotlib for chart and everything we are going to be doing. Matplotlib.pyplot as PLT. So and also the one that we are going to import now, that is Scikit-Learn. So let's say from Scikit-Learn dot linear. We just want to plot any linear regression. So that's why I import it. I want to use it. So because we are going to do simple linear regression and what do you call it again? And multiple linear regression. So these are the important library for that. So you need to know it, which is Scikit-Learn. Do you understand now? Because you didn't really do the library. But now we have also we have also we use SciPy to import the stat. So that one deal with anything related to statistics. If you want to do descriptive statistics for maybe finding mean, finding variance, finding all those stuff. So we use that one for it. Come. So we use SciPy for that. So we now say that from SciPy import start. So now after we did all this, then let's update our data. We want to update the file part that we are going to use. Are you there? So we update the part that we are going to use. So I'm thinking of, okay, now let me just write it for you so that you're able to understand. So that would be update the file part. Update the file part below to point your download folder. So me, I'm using download folder. Me, I don't know about you. So you can use documents. You just add document folder. So now here if you want to update the file path, so you go to your this thing, you write the code like this, you write file underscore path. Are you there? So underscore path is equal to, so you go and copy your file path, then put it there on that as well. Let me go and copy my own file. So you copy and paste it here under this. Then after that, we also need to adjust it. And the adjustment you are going to do now is that you are going to put the slash twice inside the part. So that means here under the cpd, we have the pd, the import the step here. I'm looking at the code though. For the for the, okay. I'm coming. I want to do something here. So it's supposed to be exe. I think it should be df, that data frame is equal to, come, so it's equal to pd because it's data frame. So now we have it to be read, to read exe because it's exe file that are going to load. Read underscore exe. I think you are getting what I'm doing. It's exe now. I'm coming. Five parts. These are five parts. Okay. Now let me put the stash here. So we will later write the code for that exe. But let me just put the two slash here under this one. So now after you are done with this, then now come here. You will now use your this thing, your code, to read the file. You understand? So now here, let me read the file now. So now say that load the data set. I want to load data set now. I want to do it step by step. I want to do it together, but let me just do it step by step so that I'm able to understand. So that will be df is equal to pd dot read underscore exe, open bracket file. You know that you already use that one to represent file path. Just put underscore path inside your bracket. Then for us to display it now, we write display the first row, the first few row. So we want to display the first few row. That will be print few rows, first rows, 5 rows of the data set. So we want to display the first 5 rows of the data set. So then close the bracket. So now print open bracket. So now after you are done with this, let's display it and see what it's going to give us. Let's display it and see what it's going to give us. Can you see my code very well? So now let's display it and see the head for our data set. It's bringing 6,000 valid escape. That's from the part. So let me change this instead of C only. So let's put R here. Do you understand? So and also the R is going to read. Then let me remove this slash two slash. So after that, let's try it again. Skate learning. Okay. Now is SK learn. This one too Scikit and Matplotlib. So that brought up the result for us. So we have five row here in our head of this data set here. For the first one, we have the date, we have the product ID, we have the product name, we have the quantity sold, we have the price per unit. So and also we have the total sales, customer ID, store location, discount, apply. So those are the data set and headings. It has print the head for us. So now we are going to data cleaning. Have you done that? Jẹ́ mọ̀ bóyá ẹ ti ṣe o ti. Okay. Step two. The step two now is to do data cleaning. So let me do explanation, a brief explanation on that. So if you are going to, or are you sending the note? Eh? Hello? Or are you sending the note? So now here for this one, we want to look at the explanation of data cleaning. So when we're talking about data cleaning, so we want to before analyzing the data, anything you're analyzing. So you have to clean your data first. So and how can you do that? So these are the steps that you must ensure that it is clean. So now and also The next one that is very good is also to do, we need to check, you have to check for any missing value in your data set. So don't forget this. Check for any missing values that could lead to error in your this thing, or let's say distort our analysis. So if you have any empty this thing, empty column, is going to distort your analysis, it's going to be bringing error for you. So and also here, what we are going to do is that we fill all the missing value, all the missing numeric, I'm coming, let me write that so that you're able to see all the missing numerical values, numerical value with the column name. So this is what we are going to do. Let me run so that we can go to new shell. So under the data cleaning, you before analyzing the data, we must ensure it is clean. So that's the first step. Then we check for any missing value that could distort your analysis. Then the third one, what you are going to do is that you want to fill the missing numerical value with column name. So now for the first one, we want to check. Okay. So Python is very sweet, and a lot of opportunity that if you grab it is going to be. So data cleaning now is very crucial. So before you analyze the data, you must ensure it is clean. Then you check for the missing value in your data set so that that one cannot be distort your analysis. And also we want to fill the numerical value with column. So that means any numerical value that have missing value, we will use column name to be there. So everything that is there, so the value that doesn't feasible, that we cannot see in our data column, so we replace everything empty column with the main of the data set. So and that can be easily done with pandas. If you are back, let me know. Hello. Hello. Okay. So we want to check for the missing value. We want to check for the missing value first. So and if you want to check for the missing value, you will print open bracket missing values column. So and after you print missing value in each column, So that means in all your data column, can you can you please mute your speaker? Please mute your speaker so that so we want to print all the missing value here. So in each column, that means in all the our column now. So all the missing value will be clear away using this prompt, using this code. So now then we also want to print, so print the df, that's data frame dot is null, is none. So that is none is that it's going to remove all the non-vacant value in our data set. So when you use none, that means there's empty stuff. So it's going to remove every empty bracket, every empty slash in our file. So and also if you write this code finish, then we also want to fill, because the question that fill with the numerical value with the column, we will fill the missing numerical value with column mean. So we want to fill the missing value now. So now we say fill is none, open bracket. It will remove empty cells in our data set. So now here for the fill missing value with the column, okay, let me write it so that we will so for the fill missing value in the columns now. So we replace with the mean for each column, that means for numerical column. So and our numerical column will be replaced by mean. So now and this is how to do that. I fill the missing column mean for numerical column. So now for this one, we will just write data frame dot fill. Are you there? Then write fill now. So that's then non and non value anywhere that doesn't have any value. So fill na, that's fill now, open bracket df dot main. So and after you write this, then you now open bracket again, so for the empty, so that you can replace any empty site like this in that bracket with the what, with the main. So now you write comma, then in place, in place is equal to true. So you close the bracket. So the reason why we put this, are you there? So we want to feed the missing column main for numerical column. So the data frame that we have is all this here at the top. Then we want to use main to replace everywhere that is empty. So all the data set that we have, so maybe you have 50, you have 4 and 500, we will calculate everything here and divided by the occurrence value of each. So we get the mean of it. So we want our this thing to do it for each every column in our data set. So and how can we do that? We have to put the data frame dot fill now. That is the function. So open bracket data frame dot main. So that means you want to replace the data frame now with what? Data main. Data frame with the main. So after you write the main, then close the bracket, then now you in place it. So whenever you see the thing as you replace everything what? In place it with the true. That means all the value that you are going to have will be mean. So and if it is mean, it is true. If it's not mean, it is false. Do you understand? Hello? So here now we are going to verify. Let's say verify that the missing value have have handled, let me say have handled the normal this thing have handled. So if you want to verify that the missing value have been handled, let me put been handled. So we want to verify that the missing value has been handled. So this is how to go about that. You print open bracket, put the quotation mark, then put the slash like this, then write n after, filling missing value. So then we are going to close the bracket again. So that means here we are going to print n after filling the missing value. So here what we are going to print now is that we have filled our all the cells, empty cells that inside the data set with the mean. So and because you have filled it according to this one now, for this code, fill na dot data frame mean in place with the what, with the true. So we are going to print n after, so after filling the missing value, so that e can give us the actual value which is mean for the data set now. So now let's also print, I'm coming, let me go, let me bring this one back a bit. Let's also print open bracket, I'm coming. Let's also print the data frame dot is null, is non open bracket dot sum open bracket. So here the data frame is none, so we want to print that one too as well, because we say that print the is not missing value here. So and also print the data frame. So this one is for checking the missing value in our data set. So if you want to check, you print the missing value in each column. So if you want to check is non value, you will print the is non value too as well. But now after you have done the checking and everything, you have found out that there's no missing value again. So you need to print n after filling the missing value to correlate your data set, to make everything what, being clean, being removing all the empty column, and also look so normal, like normal clean data. You understand now? So with this now, let's print. So we want to print, and we print 000 none missing value in each column. So the date is 0, the product ID is 0, the quantity sold also is 0. What what is this error that is bringing here? Okay, we say that the df in place true, another frame. I'm coming. Let me check my code first. This is the data frame here. The missing error, the df in place the truth. Yeah, okay. The df is none. It's also two. Okay. Our data set has been clean already, but this error that is bringing down here, I don't even understand. So where the error come from? Here we have this to be in place. Okay. The main, the df main open in place. Maybe by under the numerical, the missing column numerical this df. Yes now. So like want to convert, you don't understand what I'm saying. That all the missing column here, all the missing column, it should be converted to main. So you understand? So every numerical column now is will be converted to mean. So that's what we are trying to do. And this df is after the mean, fill in the mean value. What is there is no final open bracket df dot mean. Okay. The feature is also here. Okay. Type 1 error for this. I'm coming. Oh, I can't really get what is happening. Let me just let me use my artificial intelligence. So when you're writing your code and you find any error, you can consult AI. Do you understand? For correction, so that you can put it through. Let's see where the mistake come from. The failure in place. Okay. So that place is where the error come from. So let's go and correct it. Failure in place. Do this. So now let's run it again. It's run perfectly now. So that's just the only that's the where the issue come out from. So instead of us only is equal to true, so 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 just that's just the place where the mistake is. You feel now. So it has removed the column. Okay, print the feel now. So that will be df dot mean numerical only is equal to true. Instead of using what do you put there before? Instead of using main open bracket alone, so we will put numerical underscore only is equal to true. So now let's go back to the same error here. Is numeric. Okay, that's how to clean our data set. That's how to clean it. So now I want to go to descriptive. Under this one, this is step 3. So descriptive, this is 36. Under this one, the explanation is going to be the first one. We will find the descriptive statistics. In case you see anyone that want to join us, you can approve the person. Provide a summary. Okay. So the civil statistics provide the summary. Are we there? So it provides the summary of the data set that we have. So let's say that, let me say, of the data set. I've done write it finish. Of the data set. So now for this one now, for the next one, also we are going to calculate key, let me say, key metrics. And the key metrics are, you can mention them, such as what? Such as what? You know it now. Such as mean, median, and what? More than, yes, standard abi, standard deviation. Yes, and what again? Hello, Baba. And what? Variance. Variance. Yeah, variance. VANCE. So now, also we are going to also look at, we also need to understand the central tendency. I don't know if you know central tendencies and spread. We also need to understand the central tendency and spread of the data set. So now, for us to display the same statistics, let me go to new cell. So here, for us to display the same statistics of the data set we are working with, so we just write print. Let me write what you are going to do. Display the summary of statistics for all numerics, for all numerical column, because the same statistic can only work for numerical column o. You cannot use the same statistic for something like maybe state name or the first name, last name, or anything letters. You can't use the same statistic for it. So you can only calculate the column that have numerics value, that have figures, that have numbers. So those are the column that is going to focus on to calculate this, the statistics, the summary, data summaries of the statistics. We can only calculate only column that have figures, only column that have numbers. Do you understand? It cannot calculate the column that have maybe letters like first name, last name, maybe the state name, the region name, the other categories name, or the product name. You understand? So you can't calculate all those kind of column. So it only focus on the KPI. That means the yes, alphabetical and no, numerical column. So that's just it. So now we say print. No, you cannot calculate alphabetical column. It's only numerical column that you can calculate. So print, you put the quotation mark, then write descriptive statistics. Then after you write the statistics, then you put this one here, then put the quotation mark here again and close the bracket. So then now also say print open bracket df dot describe. You remember this thing now? How to describe your data. Instead of you doing modern standard kinikan one by one, so you just use print df dot describe. It's going to describe all the data for you once, everything. So now after you do that, then let's say you want to find the additional measure additional measure for the total sale. Additional measure for total sales. So if you want to find that, you have to also print the additional measure. So that we print open bracket, put the quotation mark, then put the slash like this, then have n additional descriptive metrics for total. Okay, that way for total underscore sales. So because that's what's inside our data set. So that underscore sales, then you put the quotation mark again at last. Yeah, make sure you close your bracket. So also want to print the mean too. Let's say we want to print the mean, come open bracket, capital letter, mean, command df, command data frame. So that's all. Can you see that? So we have the descriptive statistics of all of them. This descriptive statistics, I mistakenly write descriptive should be descriptive, okay, p. So this one descriptive, this one is correct. So let me run it again. The spelling is not correct. So now we have it to be this. This is our descriptive statistics. So our descriptive statistics is for the mean, we have this value for the mean here. For the quantity, product ID, so for the quantity sold, for the price unit, all of them you did this once. So we have the mean, the count, the minimum, the 20 percentage rate, 50 percentage rate, 75 percentage rate, the maximum and standard deviation for each all of them. So it's all there. So and also we also have the total sales. We did for total sales too as well. We did one by one. So for the total sales, we have the customer ID, discount apply. We did for the total sales too, for the count, for the maximum, minimum, standard deviation. So and also for the additional descriptive, did for that one too as well. Are we there? So this for that one too should be this. So you do the data summary for each every one of the column that have numeric value. So that's all about. Where is that? This place. Okay. For total sales. Yeah. You did not list everything. You just this. You can't list it all. You can't list it all. No. You don't want to list everything. So it's not about cleaning data. Yeah. Do you understand? You just do the summary of everything. If you want to list, it's going to be long. You know that data set is up to 500 something, 500 list. So you can't list everything. That's why I put the dot there. So you understand now? Hello, do you understand now? Yeah. So now let's go to next one. So after we have done the distributed statistic, that is step 3. So we want to do data visualization using our data set. And the most cumbersome library for that is what? Effective library for data visualization is what? Hello, sir. The most effective, the most effective library for data visualization is what? Matplotlib. Very good. Matplotlib. So that's it. Explanation. You are giving me joy. You are giving me joy, sir. So now we have the explanation. So here under the explanation, I want to find the visualization. Are you there? So visualization. Now we said ATI1. Visualization. Okay. I want to visualize the data using help review math pattern. Help review patterns. So and also I want us to find the patterns and distribution. The patterns and distribution of our data set. So and also we also going to create histogram. I'm coming. We will create histogram. We will create. I'm coming. Let me write this way. Create. We create a histogram of the total sales underscore sales total sales. Then write column to visualize its distribution. Okay. We create histogram of total sale column to visualize its distribution. So now and also we also need to the plot a histogram of the total sale. So in our data we'll plot the histogram of the total sales. So that says column I'm coming. That says column to visualize okay. I think I have done that before. That says column with ID. That says column with KDE. That KDE stand for kernel density. You may not hear it before. KDE. With KDE, that's the kernel density estimate. So We want to plot the histogram of the total sales so that you can fit into KDE, and the KDE stand for kernel density estimate. Do you get that now? So now, for us to do that now, she has not join it. Could it join up? So I mean the person that I told you that is going to join. So say PLT figure. Okay, oh, have a fig size. Okay, fig size 8 comma 6. So 8 comma 6, then we close the two bracket. And also for SNS, you write is plot, the histogram plot. So that will be data frame open bracket. You now write the nǹkan tẹ́ fẹ́ plot, which is total sale, right? So total sales, have a total underscore sales, then put the quotation mark again, then close the bracket. After that, because you are going to find the KDE, don't forget, so write bin is equal to bins is equal to 20, comma, and KDE will now equal to true. That is knet. So after we do that finish, then we go to also, we are going to plot plt dot title react. So dot title, plt dot title, open bracket, distribution of total sales. So now we close the bracket again. So that means title ṣá ti wà lélẹ̀, distribution of total sales. Do you understand now? So now we also want to plot our yx label. Our x label, mo gba label yẹn ṣá, that will be BLA, yes, label. So our x label, open bracket, quotation mark, that will be total sales, then put the quotation mark. So for our x label, so now for our y label, as plt dot y label. Our y label is going to be what? We use that one to be frequency. So now for this one, I want to plot show bracket. So now let's print this, see what it's going to give us. Figures, fixed size 8 to 6, then histogram plot. The space is too much, abi? Okay. There's only one that's supposed to be there. Just true. So now let me More Python code with wahala because of semicolon now it's not going. So now this is it. Yeah, you have done with the second one. It is how to plot the correlation mass. Abi is it second or four? That's four. So we are going to five now. So I've done with the data visualization. So now for now, I there. So let me scroll up so that you can see my code. If I don't just say I'm done oh, so that I will know. You are done. Alright. So the next step, which is step six, you know that we are still using this data file for all this. So now step six is going to be this. So we want to find the simple linear regression. This simple linear regression, that my brother I told you about, he spent like 2 days before you can do it. Oh, I'm telling you. So it's not. I don't know how they did this tutorial on Udemy or everything. So yeah, we want to do simple linear regression and also multiple linear regression. So but let's do simple linear regression first. Simple linear regression is used to model a regression. I'm coming. Model regression, model let's say a model relationship so that we're able to understand the relation. Let's say it's a model relationship between a single a single predicator, a, a single predictor and the target variable. So and also what we are going to do here now is that here let me mute your speaker. Your keyboard is shouting. So we examine here we examine how the quantity say how the quantity value quantity sold avert total sale. So we plot it again total sales. I think it's dataset that yes, dataset we did before. So we want to look at it, both of them. How the quantity sold affect the total sales. So that's what we are going to use simple linear regression to do. So now, and also we also need to train our model. It's under the data science app. Yeah, under the data science. We train the model and then plot the regression. Regression line. Mr. P. Mr. PC over the over the actual I'm coming over the actual data. Question your question is very funny, serious. It's under the ilẹ̀pẹ̀lẹ̀ kan náà. It's under the data analysis or data science. Linear regression is for both. So we use it for both data science and data analysis. You understand? So um you can master data and regression analysis in any field, both of the two field, both in data science and in data, but it depends on the tools you are using. You understand? So for data science now, we are using Pythons, all the languages to model our data, like RStudio and SQL, Pythons, so on and so forth, to performing all these analysis that are doing. So that in Excel now we have regression and correlation also in Excel. So but that one is limited to normal basic analysis. But this one is advanced one, you understand? So you have to know it. You have to know it. How to use Python to do it. To do all those things you are doing in Excel, all those things you are doing in Power BI, all those you have to master. So but the thing is that Python can also build dashboard, but it's not that beautiful way like that. But it can still build dashboard. If you import dash in it like this, you can see some of my project now. The one that I posted on my status there, relating to that analysis engine. You see how it look like a normal dashboard. So I paint it to come up in a web form, web-based form, website that you can load your data into it and it's going to visualize everything for you. It's going to do analysis for you. So it depends on you how you want to navigate to. So now I want to create and train our model. I said create and train the linear model. So here, if you want to linear regression, it's a linear regression. Create and train the linear regression model. So if you want to train the linear regression model, but before we go into this, I want us to do something first. Let me calm down. Let me calm this one down. So what we are going to do first is that we want to define the predictor, because according to that simplify the model relationship between the single predictors and target variable. You have to define your predictor first. So say define predictor, define predictors x and y. So we can represent it with x and y. So our variable for this thing x and y, that means for the quantity sold and total sales, we want to represent them with x and y. You understand? So we pick our dependent variable and independent variable between both of them. So now and target variable, okay, variable y. So now here we are going to define our predictor. So for us to define the predictor, we say that x is equal to df open bracket, you open it twice. So then you now put the quotation mark and write quantity underscore sold. You put the quotation mark again, then close the bracket twice again, then come back to this one, then write y is equal to df, then open the bracket, write total sales. Okay, sales. So now then put the quotation mark and put the we have defined our predictor now. Now the next thing I'm going to do now is that we want to create a train model, which we are doing here before. Well, create a train model. So for us to do that, press enter. So for us to do that, we write model is equal to, what's our model name now? Our model name, eh? Our model name is simple linear regression now. So if you want to predict your model now, just write linear regression. You understand? Hello? The meeting has ended. Okay. So your model is what? Linear regression. So that's just it. So write linear regression. So that will be dr. So then you close the bracket twice. So now for the next one, you also have to write the model that fit. So write model dot fit open bracket x comma y. So I'll define your model like that. Create a linear model. So we have created our training model. So now for the next one we are going to do now, that I want to make a prediction predictions using the train model. So for us to make a prediction using the train model now, so you just say y underscore p. I'm coming. So that y is also p or p pred. So that will be pred, that is predictions, is equal to what? Model prediction. Model dot predict open bracket x. So predict the model for x. So y predict is equal to model predict for x. So now let's plot. So we want to plot the graph, the regression, linear. Sir? No, now what I did here is that we already say y predict. You understand? So we have used y predict to equal to model predict for x. So that means they are interwoven. They want to be in together. So we want to find the relationship between the two model. Do you get? So you don't have to also make a prediction for what again? For y again. So because you want to make a prediction using the train model. So and the train model is what? The train model is for what? The model we created is linear regression. And the model fit is x and y, you understand? So we say y underscore predict, so is always equal to the model dot predict for x. So you don't also need to what, write x predict again. That's just all we need. So now for us to plot the actual, I'm coming, the actual data point, data point, and the regression line. So we want to plot the actual data point and the regression line. So how can we plot that? We write plt dot figure open brackets figure size. Let me write fig size. Okay, fig size. So now fig size is equal to what? Remember, the size that we use for this one is what? 8 by 6 abi. Let's use 8 by 6 as well for this. That will be 8 by 6. So now close the bracket, close it twice. Then for this one to write plt dot scatter plot. Just write scatter. Then we write x. Our x is our model that we derive. So use x, y, comma. Now let's give it the color. Color to fẹ́ ní search bar. So our color is going to be blue. Yes, comma. And also let's say label. We want to label it with actual date, actual data I mean. So the actual data, then you close the bracket. So now plt dot plot, complete, it should be dot plot. Yes, dot plot open bracket x. So that's our train model, don't forget. So we have x here, command y, then underscore predict. This is a predicting model. You write print, command color, phone on color. So the color is going to be, let's say, red, command label. Are we all there? Command label is equal to regression line. So label wa máa jẹ́, for the x distance is going to be regression line. So put the regression line at the top, divided, and regression line is going to be red. So now, and also we also want to plot the title. plt.title. So our title is going to be open bracket linear regression line. Linear regression line. Let me use only linear regression. Then we have quantity, right? Quantity sold. So I have quantity sold versus total sales. Total underscore sales. So hence we move on to the plot x label. So that will be plt dot x label. So we want to plot the x label now to be quantity sold. So that will be quantity underscore sold. Don't forget to put the quotation that it will not bring error. So after you put the quantity sold, let's double quote it. So then close it. For where? Okay, quantity. Okay, yeah, yeah, good. No, 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 no. You don't need it. You don't need it. This one too, you don't need it. Let me just leave like that. So let's just leave like that. You understand? So now here we want to plot prt dot y label. Good of you. So put the total, that will be total sales abi. Total sales. Close the one. So now for the prt, you now plot the legend chart. It's called legend chart because it's working with the linear regression. So we use legend instead of writing it in full regression. Just legend open bracket. You understand? Linear regression chart. Then we say prt dot show open bracket. So let's run this and see our result. Let's bring it here. So I have the actual point regression SY for this. For under the scatter abi, instead of small x abi. Okay, 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 okay. So this will be x. Okay. So that's all. So now that's all. So here we have our chart. This is linear regression quantity versus sold total sales. So and we got our answer to be this. Pium, pium. So here let's interpret the actual total regression here. Here we have our scatter plot moving from this range here. So and also the data set we have the total sales up to this size 2,500 abi 25,000. So and we see that the plot for each every one of them are being fixed in here. So and you can see all their dot, all their point has been reflecting each for each sales and for each quantity sold. So each point has been reflecting here, so against each other. So if you look at it very well, you will see that there are, according to this data set, they have a straight line here, this one too straight line, this one too straight line, this one too straight line. So there are correlation, a good relation, strong relationship between quantity sold and total sales. The reason why is because, let me write this thing very well, quantity. So the reason why is because the line are very fixed and it's very good. They are working straight. So if there's no relationship between them, you will see your plot toma was scattered. It will not be straight like this. Are you there? Are you understanding me? So it will not be straight like it will be scattered. It will not be fixed. So it's telling us that as this the total sales is also growing, the quantity sold too was also what? Also growing. So they have the same relationship, they have the same correlation between regression between each every one of them. So do you understand now? So that's just the a little brief explanation I can give about it. Okay. Can you see it now?